Hello everyone, I am Madhura. Our assignment is the web-based visualizer for structural representation of the C program. Introduction. Artificial intelligence coding assistants such as ChatGPT, Cloud Code, Gemini, and GitHub Copilot do not process the source code as the plain text. They first analyze the code and structure by dividing it into a tokens, understanding the syntax, identify the execution of paths, and tracking the data dependencies. This analysis helps to generate the accurate suggestions, explanations, and bug fixes. In this assignment, a web-based visualizer is developed to demonstrate the C program, how it is transformed into a different structural representations such as tokens, abstractions, syntax tree, control flow diagram, and data flow graph, and code property graph. These representations helps in understanding the behavior and the logic of the program. This page is the input interface of the structural representation of the C program visualizer. This section allows the user to enter or edit the C program that will analyzed by the system. A sample C program is already provided in the text area for demonstration purpose. The program shown performs the following operations. It declares the three integers variables a, b, and c. Assign the value a equal to 5, b equal to 10. Uses an if-else condition to compare a and b. If a is less than b, then c is equal to a plus b. Otherwise, c is equals to a minus b. Prints the value of c and terminates the program using the return 0. The analysis button is used to start the program analysis process. When clicked, the system process the entered C code and generates the different structural representations such as tokens, breaks the program into keywords, identifiers, operators, constant and symbols. Abstract syntax tree displays the hierarchical structure of the program. Control flow graph shows the execution of the statements and decision points. Data flow graph illustrates how data moves between the variables and operations. Code property graph combines the AST, CFG, and DFG into a unified representation.
Now I will explain lexical analysis. It is the first phase of compiler. The image show how a sources program is broke into smaller units called tokens. A tokens is the main smallest element in the program. During lexical analysis, the compiler scans the sources code character by chapter and groups into tokens. We can see different types of tokens represented by different colors. Keywords like purple, these are received words in the programming language such as int, if, else, print, and return. They they have predefined meanings and cannot be used as variable names. Next, identifier. This represent name given by the program such as variables and functions. Example, main a, b, c. Next, operators. It represent blue color. Operators perform operation on data. Example including equals, plus. Next, constant. It's represent orange color. Constant or fixed values in this program, uh, 5, 10, and 0. And the string or constant, Delimiters it represent gray. It separated different part of the program. Example including uh, common brackets, semicolon. Next, the lexical analysis reads the sources code, identifies these tokens, removes unnecessary spaces and comments, and passes the token stream to the next page, which is the syntax analysis.
Myself Danya, abstract syntax tree is a tree representation of program structure. It shows how different statements and expression in a program are organized and related to each other. Explanation of the diagram. Program root node. The topmost node represents the entire program. All program components are connected under this node. Function node represents the function or main block of the program. Contains declaration and executable statements. Declaration ABC variables A, B and C are declared. AST stores this declaration as separate node. If statement represent a decision making structure based on condition one of the branches executed. Expression C equals A plus B. Assignment operation where the sum A and B is stored in C. Expression C equals A minus B. Assignment operation where the difference of A and B is stored in C. Printf statement displays the value of C as output. Importance of AST represents base program logic in a structured form used by compiler for semantic analysis and code optimization. Makes program processing easier than working with raw source code. This AST diagram shows how program is broken into hierarchical nodes such as declarations, conditional statements, expressions and output statements, helping the compiler understand and process the program efficiently.
Myself, Kavarna, and my topic is a control flow graph (CFG). It is a simple C program where a CFG shows how the program executes step by step and how control moves between states and decisions. In the explanation of the flow, where it starts, the program execution begins from the start node, and the declarations where it variables and declares here for example C in C int a comma b comma c, uh, and next is decision condition where a less than b. This is the decision node where in a diamond shape, and the condition checks whether a is less than b. If the condition is true, then the execution follows the left branch. If the condition is false, then it follows the right branch. uh, in true branch, if a less than b is true, then c is equals to a plus b. If the values of A and B are added and stored in the C, then the false branch, if A less than B is false, it executes C is equals to A minus B. Then the value of A is subtracted from A. And here it merges the at the print f of both branches joins and together and executes the C. Where the prints where this prints the value of a C. And also next it returns the program finishes executions, and at the end the execution terminates at the end point, and it the symbols we used in the CFGs are circle, oval, where it is used for a start and or a end. And next is a rectangle shape. It indicates the statements or the operations. And next diamond, it indicates decision or condition, and in arrows it indicates the follows of execution. Where in purpose of a CFG are like this. A control flow graph is used to understand program execution flow, analyze conditions and branches, and it detects the logical errors, and it also helps in a compiler design and software testing, and it also performs the optimizing and debugging. Next will be continued by Lasya Pishet.
Hello, I am Lasya Pishetti. Now I will be explaining the data flow graph, DFG. The data flow graph represents how data flows from variables during the program execution. It focuses on variable dependencies and arithmetic operators rather than program flow control. For the statement C is equals to A plus B, the DFG is shown as A and B input variables plus is the operator node. The values of A and B flows into the plus operator. The result of the addition flows into the variable C. The representation is shown here. The importance of DFG is it tracks the variable dependencies. Like here, the A and B are dependent on the plus operator. Helps identify how values are computed, uses in the compiler optimization, supports program analysis and debugging, used by AI based code understanding systems. Observation from the output, the generated GFG correctly shows the variable C depends on variable A and B through the addition operation. So now I will be explaining the code property graph. The code property graph is a unified representation that combines AST, that is abstract syntax tree. It explains the program structure. CFG, control flow graph, it's the execution flow, and the data flow graph, it is the data dependencies. The CFG integrates information from all the three nodes into a single model. The structure is shown here. In the visualization, the purple edge represents the AST and the blue arrow represents the CFG and the red arrow represents the DFG relationships. All graphs contribute information to the central CPG node. Importance of CPG provides a complete representation of a source code, whether it is a visualization, the program flow, and a execution flow. Helps detects bugs and vulnerabilities, used in static code analysis, supports code search and program comprehension, widely used in modern AI powered code assistants. The generated CPG successfully combines AST, CFG and DFG information into a single graph, demonstrating how different programs representation works together for advanced code analysis. Thank you.